Scaled diagrams. The picture on the right shows a model of a car which is a replica of the real car. So this is a small little car. It is 7 centimeters in length, which is obviously quite small. Models like these were originally made as toys to fit into a matchbox. So this is a very small little 7 centimeter long car. The scale is 1 to 87. So the scale is 1 to 87. This means that the real car is 87 times the size of the car in the picture. So the real car is 87 times bigger than this. The model is 7 centimeters long. So the length of the real car is 7 times 87, which is 609 centimeters. So the real car's length is 609 centimeters. The picture is an example of a scaled diagram. Scale diagrams have the same shape as the real object, but a different size. Architects and engineers use scale diagrams of buildings and roads so that the builder can construct them properly. When we look at a map or a house plan, we are looking at a scale diagram. The diagram shows a plan for an extension to a house. So we see that they want to extend and build a bedroom and a bathroom onto the side of a house. The scale used is 1 to 50. So in our small drawing, our small little plan, we have the length of the bedroom is 8 centimeters. So obviously the bedroom won't be 8 centimeters in real life because that would be tiny and a person couldn't fit inside it. And the width on the plan is 12 centimeters for the bedroom, and the width on the plan for the bathroom is 6 centimeters. So this is a small little plan drawn in centimeters. So the scale of this plan is 1 to 50. So that means in real life, this will be 50 times bigger than what's on the map or what's on the plan. So this 8 centimeters length for the bedroom will be 50 times bigger. The 12 centimeters width for the bedroom will be 50 times longer. And the 6 centimeter width for the bathroom will be 50 times longer as well. Question 1. Find the actual dimensions of the rooms. So in real life. So this is the small measurements on the plan. What are the big measurements in real life? And part 2. If the sitting room in the house is 5.7 meters by 4.7 meters, what would the dimensions of this room on the plan be? So we'll start off with part 1. Find the actual dimensions of these rooms. So we want to change the small plan measurements into the big real life measurements. So first of all, we need to go back to the fact that the scale is 1 to 50. So 1 centimeter on the plan equals 50 centimeters in real life or in reality. So 8 centimeters on the plan is going to be 8 times 50 centimeters in reality, which is 400 centimeters. So this 8 centimeters length of the bedroom wall is actually 400 centimeters in real life. So remember, if we're going from a map to real life, so the map to real, we're going from something small to something big, so we're going to multiply by the scale factor. If we're going from something small to something big, we're getting bigger, so we're multiplying. So that's why we multiplied by 50 here, we did not divide. And when you're dealing with scale, you're always either multiplying or dividing. You would not add or subtract. So when we are going from a map into real life, reality, we're going from something small to something big, so we multiply by the scale factor. So we said 8 centimeters times 50 is 400 centimeters. So in real life, the bedroom wall is 400 centimeters long. Next we have the width of the bedroom, which is 12 centimeters on the map. Again, we're going to multiply by 50. So 12 centimeters on the plan is equal to 12 times 50 centimeters in reality, and 12 times 50 is 600 centimeters. So this blue wall here of the bedroom is actually 600 centimeters in real life. Remember, we're going from the map to real. We're going from small to big, so we multiply by the scale factor, we don't divide. And lastly, we have the bathroom wall, which is 6 centimetres wide. So in the same way, 6 centimetres on the plan is equal to 6 multiplied by 50. We're multiplying by the scale factor, centimetres in reality, and 6 times 50 is 300 centimetres. So this 6 centimetres on the small little plan is actually 300 centimetres in real life. Now we're after getting the measurements for the yellow wall, the blue wall and the green wall, but now we need to get the dimensions of the room. So focusing in on the bedroom now, we know that the bedroom measures 600 centimetres by 400 centimetres. So this is how we would describe the dimensions. So it's 600 centimetres by 400 centimetres. And changing from centimetres into metres, we divide by 100. So 600 divided by 100 is 6 metres. And 400 divided by 100 is 4 metres. So the dimensions of the bedroom is 6 metres by 4 metres in real life. So instead of using the word by, you could have put a multiplication symbol if you wanted. So in real life, the bedroom is 6 metres by 4 metres. And now we're going to do the same with the bathroom. So we know that the green wall is 6 centimetres on the plan, which is 300 centimetres in real life. But this other wall matches the bedroom wall, the yellow wall. So this is also 8 centimetres on the plan and 400 centimetres in real life. So the bathroom's dimensions are 300 centimetres by 400 centimetres. And again, dividing 300 by 100 gives us 3 metres. And dividing 400 by 100 gives us 4 metres. So we can say the actual dimensions of the bathroom are going to be 3 metres by 4 metres in real life. So remember, in this question, part 1, we went from the map to real. We went from small to big, so we multiply by the scale factor. In the next question, you're going to see where we're doing the opposite. We'll be going from the real dimensions, so 5.7 metres and 4.5 metres for the sitting room. They're the real dimensions. And we'll be trying to figure out what those dimensions are on the map. So we'll be going from real to map, which means going from big to small, so we'll divide by the scale factor. So again, question 2. If the sitting room in the house is 5.7 metres by 4.5 metres, what would the dimensions of this room be on the plan? So the first thing we want to do is change from metres into centimetres. So the sitting room is 5.7 metres by 4.5 metres. Multiplying both of these by 100 changes into centimetres. So we get 570 centimetres by 450 centimetres. So 1 divided by 50 centimetres on the plan is 1 centimetre in reality. Remember, if we're going from the real measurements down to the plan, going from big to small, we're dividing. So 1 centimetre on the plan is 50 centimetres in reality. So we do the opposite to part 1. This time we divide each measurement by 50 to get the plan measurements. So the dimensions on the plan, so 570 centimetres divided by 50 give us 11.4 centimetres. So that's on the map, it would be 11.4 centimetres. And 450 centimetres divided by 50 centimetres gives us 9 centimetres. So we went from 5.7 metres by 4.5 metres. Changing that into centimetres, that was 570 centimetres by 450 centimetres. So this is the real measurements in real life of the actual sitting room. We divided 570 and 450 by 50. We're dividing both of them by the scale factor. And we got 11.4 centimetres by 9 centimetres. So these are the dimensions on the plan, on the map. So this is what the sitting room would look like if we drew it onto the house. So 11.4 centimetres is the length of the room and 9 centimetres is the width of the room. So remember, this 11.4 centimetres actually represents 5.7 metres in real life, and this 9 centimetres actually represents 4.5 metres in real life. So it's very important to note, if we're going from real measurements to the map, we're going from big to small, so we divide by the scale factor. Whereas in part 1, we were going from the map to real measurements, we're going from small to big, so we multiplied by the scale factor. This is a scaled map of Ireland using the scale 1 to 6 million. Using the information on the scale diagram, calculate the following. Part 1, the straight line distance from Cork to Donegal to the nearest kilometre. So we want to figure out what this is to the nearest kilometre. On the little map, it's 5.5 centimetres. We want to figure out what is that in kilometres if the scale is 1 to 6 million. And part 2, if the direct distance between Limerick and Belfast is 276 kilometres, so to get from Limerick to Belfast in real life, the straight line distance is 276 kilometres. What distance would this measure on the diagram? What would it be in centimetres on the diagram if the scale is 1 to 6 million? Okay, so before we even start to answer part 1 and part 2, we need to rewrite 1 to 6 million. This scale, the numbers are too big to work with, so we're going to rewrite this. So 1 to 6 million means every 1 centimetre on our map represents 6 million centimetres in real life. But when we're talking about going from Cork to Donegal or Limerick to Belfast, we wouldn't talk about going there in centimetres. And we wouldn't even talk about going there in metres either. We would talk about kilometres, because when we're talking about far distances, we talk about kilometres. So we need to change 6 million centimetres, first of all into metres by dividing by 100, and then into kilometres by dividing by 1,000. So the scale reads 1 centimetre equals 6 million centimetres. So each 1 centimetre on the diagram represents an actual distance of 6 million centimetres in real life. As we normally measure distances in kilometres, we need to convert 6 million centimetres into kilometres. So first of all, we have to change centimetres into metres. We can't jump ahead and change into kilometres. We're going to first of all change from centimetres into metres. And since there's 100 centimetres in a metre, we divide by 100. So 6 million divided by 100 is 60,000 metres. So 6 million centimetres is 60,000 metres. Now we need to change from metres into kilometres. So to change from metres into kilometres, we divide by 1,000 because there's 1,000 metres in a kilometre. So 60,000 metres divided by 1,000 is 60 kilometres. So 1 centimetre on our map is actually 60 kilometres in real life. So our scale can now be written as 1 centimetre equals 60 kilometres. So we're going to use this to work out part 1 and part 2. We will no longer use the original scale given. But 1 to 6 million actually means 1 centimetre equals 60 kilometres. They mean the exact same thing. But it's just that it's easier for us to work with kilometres than to work with millions of centimetres. So part 1. Using the information on the scale diagram, calculate the following. The straight line distance from Cork to Donegal to the nearest kilometre. So we can see on the map, to go from Donegal to Cork or Cork to Donegal, the straight line distance is 5.5 centimetres. Now we know that 1 centimetre on the map represents 60 kilometres, so we're going to multiply by 60. So scale 1 centimetre equals 60 kilometres, and the distance from Cork to Donegal on the map is 5.5 centimetres. So the actual distance is 5.5 multiplied by 60, which is 330 kilometres. So in real life, that straight line distance from Cork to Donegal is 330 kilometres. So just like in the previous example, if we're going from the map to real, we're going from small to big, we multiply by the scale factor. So we multiplied by 60. Part 2. If the direct distance between Limerick and Belfast is 276 kilometres, what distance would this measure on the diagram? So now we're going from the actual measurement, we're going from the real distance down to the map. We're going from big to small, so this time we will divide by the scale factor. And remember, the scale factor is 1 centimetre equals 60 kilometres. So scale 1 centimetre equals 60 kilometres. The straight line distance between Limerick and Belfast is 276 kilometres. The scale for the diagram is 1 centimetre equals 60 kilometres. So to find the distance on the map, we need to divide 276 by 60. So 276 divided by 60 is 4.6 centimetres. So the distance between Limerick and Belfast on the map should be 4.6 centimetres. So the distance between Limerick and Belfast on the map should be 4.6 centimetres. But remember, that represents 276 kilometres in real life. So going from real measurements to the map, we're going from big to small, so we divided by the scale factor. In the previous example, we were going from the map to real measurements, we're going from small to big, so we multiplied by the scale factor.